Good morning, students. Is my screen visible to everyone? Screen is visible. Anyone can reply.
Yes, sir.
Okay, thank you. So first of all, I welcome you all for the 8th semester and final semester of your degree. As you all know, I will be handling this. Okay. So for you, I will be handling the prestressed concrete subject. The subject code is 18CV 81. Okay. I think you all heard about prestressed concrete. Ever heard or not? Prestressed concrete, or have you seen prestressed concrete elements anywhere? Any examples of prestressed concrete elements? You might have seen the railway bridges, correct? The highway bridges and metro bridges. Okay, so most of the bridges are constructed by using this prestressed concrete elements only. Okay, that prestressing either it may be done in a particular place, and the elements will be brought to the site, and they will be fixed. Okay, or else on-site pre-stressing will be done. Okay, so in most of the bridges we will use this pre-stressed concrete element. Not only the bridges, even for railway sleepers, no, for railway sleepers also we will use this pre-stressing or pre-stressed concrete elements. Whatever railway sleepers are there, they are pre-stressed elements only. Okay, and nowadays this pre-stressed concrete elements or pre-stressing technique is used in construction of buildings also. Okay, the pre-stressing of the slabs can also be done. Then pre-stressing of the beam will be done. Okay, because of this recent advances in technology, we are also adopting this pre-stressing technology for the construction of the building as well. But since long years we are using this pre-stressing technique for construction of the bridges, and there is a lot of scope for a bridge engineer in the industry. Okay, if you are thoroughly understanding this particular subject, okay, then you can learn design of pre-stressed concrete bridges. Okay, through any available softwares. If you are ready with designing a pre-stressed concrete bridge, then there are a lot of opportunities in the industries. In most of the MNCs, a lot of opportunities are there. Okay, to design a PSC bridge, you must understand the basics of pre-stressed concrete. Okay, so in this particular subject, you will be studying all the basics. Okay, all the basics of pre-stressed concrete. Okay, and you will also be designing a small some few small elements like a simply supported beam. Okay, and a few other elements, few other pre-stressed concrete elements, but not the full structure. Okay, if you are able to understand all the basics which you come across in this subject, then you can easily learn. You can go for advanced learning like design of bridges and all. Okay, and it is similar to RCC only, but the principle behind the design and construction methodology, okay, and there are few advantages of these PSC elements compared to RCC elements, and there are some disadvantages also, okay, with respect to cost and all. Okay, especially for long span structures, okay, bridges, obviously they will have a longer span, correct? Especially for the structures having long span, these PSC elements are very much suitable. Okay. So in this subject, as I said, you will be learning all the basics of prestressed concrete, and you will be learning some sample designs of the different components of a building, like column or beam, whatever. Okay. Am I audible, students? Am I audible to everyone?
Yes, sir.
Okay, thank you.
Sir.
So with this, we will start with the model 1. So model 1 is basics of PSC. In this model, we will be studying the basics of PSC. The main outcome, course outcome of this particular model is, after successful learning of this model, we will be able to describe basics of prestressed concrete structures. That's it. Okay. Now, let us understand what is the meaning of prestressed concrete. Okay. We are saying pre-stress. Let us understand what is the meaning of it. Okay. Okay. Pre-stress, as the name itself indicates, in case of pre-stressed concrete element, the pre-stressing will be done to the structural element. Okay, means the stresses are introduced to the structural element opposite to the stresses that are caused by the external loads. That is the main principle behind this pre-stressing. Okay, what we are going to do is, we are going to introduce the compressive stresses. Here you can see. Okay, here you can see the compressive stress. Today I don't have the rating pad. Yesterday only I got to know that to take the class. Maybe from the next class I will be using the rating pad, students. For today's class, you please adjust, and this will be an introductory class. There is no much need of the rating pad. I can explain it. Okay. Here the pre-stressing or pre-stresses or the stresses will be introduced into the element opposite to the stresses that are caused by the external loads. Okay. So this is the main principle behind the concept of pre-stressing. Okay. Here you can see, in case of RCC, what we'll do, what we'll call for the steel elements, we will call it as reinforcement. Okay, but in case of PSC, for the same reinforcement, we will call tendons. The technical term which we use is tendon. Okay, we'll call it as tendon or the cable. Okay, tendon or the cable. We'll call it as tendon or the cable. Okay, it is similar to the reinforcement in case of RCC structures. Okay. Here what will be done is, these tendons, the stresses will be induced to the concrete element. Okay, through this cable or the tendon, the stresses, the compressive stresses will be induced to this concrete element. Okay, so that the stresses which are caused by the external loads, either it may be dead load or live load, will be counterbalanced by the stresses which are induced into the concrete through these cables or the tendons. That is what the main principle behind this pre-stressing. Okay, here you can see a cable or tendon. For that, pre-stresses are induced. I will explain in detail how the pre-stresses are induced into the concrete element in the next topic. Okay, here you can see the compressive stresses are induced through this cable or tendon to the concrete element. Okay, in the first figure, because of this compressive stresses induced, the nature of bending pattern is shown in the second figure. You can see here. Okay, because of compressive stresses, and these compressive stresses are induced eccentrically. Okay, they are not acting through centroidal axis of the member. Am I right? It is, they are not acting through the neutral axis. They are acting at an eccentricity E from the neutral axis. Because of that, what will be the effect of these prestresses? What will be the effect of prestresses? It will cause a hogging bending of the or hogging bending moment to the beam. Okay, whatever the stresses induced, external stresses induced through the cable, they will cause hogging bending moment to the beam. Okay, and this hogging bending moment of the beam will be there for only at a condition for dead load plus pre-stress. Okay, for dead load plus pre-stress. When you apply the live load, okay, when you apply the load, including the live load and the dead load, then the stresses caused by the tail load will be opposite to this hogging bending moment. They will cause sagging bending moment to the beam. That hogging bending moment caused by the pre-stressing force and sagging bending moment which is intended to cause by live load will be counterbalanced. Then beam will be in equilibrium condition. Beam will be in equilibrium condition. In this way, whatever the bending stresses induced by the live loads are counteracted by the internal stresses or pre-stresses which are induced through the cables or the tendons. Okay, finally the beam will be in equilibrium condition. Okay, so whatever the hogging bending moment caused by the or whatever the sagging bending moment caused by the by the effect of dead load and the live load, it is counterbalanced by hogging bending moment caused by the pre-stresses. In this way, the equilibrium of the beam will be maintained. The advantage of this system is there won't be any cracks propagated throughout the life of the structure. That is the main advantage, and you can reduce the overall cross section of the beam by introducing the pre-stresses. Okay, that is the main advantage of this pre-stressed concrete elements, and even you can go for longer span elements compared to RCC. Okay, I hope you all got some idea about this concept of pre-stressing. Any doubts you have, students? Any doubts you have, you can ask before moving to the next topic. Okay. Okay, we'll move on to the next topic. Now I said the pre-stresses will be induced into the concrete. Okay, pre-stresses will be induced in the concrete. There are two main methods of pre-stressing. Okay, or there are two main methods of inducing pre-stresses into the concrete element or pre-stresses into the concrete element. First one is pre-tensioning system and second one is post-tensioning system. Okay, pre-tensioning system and post-tensioning system. And this topic is important for the point of your examination. Repeatedly this question is asked. Pre-tensioning system and post-tensioning system. There are two methods of inducing the stresses. Okay, first we will go with first one, that is pre-tensioning system. Okay, just look into the title, pre-tensioning system. Pre means what? Prior to the process, correct? Pre means prior to the process. Okay, what process here we have? We have the pre-stressing process we have. Here what will be done is the pre-stressing will be done prior to placing the concrete into the mold. Okay, here in this process you can see that a rectangular beam is being casted. Okay, a rectangular pre-stressed concrete beam is being casted. For that, initially what will be done is, as the name itself indicates, pre-tensioning system, the pre-tensioning of the cables or the tendons will be done prior to the pouring of the concrete into the mold. Okay. Initially, the tendons will be stretched by using this jacks, hydraulic jacks. Okay, stretched. Then, in the second step, the concrete will be poured into the beam. Okay, or the mold. Okay, beam mold. Then concrete is allowed to harden for required number of days, say about 20 days, 28 days. Okay, after the concrete gets sufficient hardening, then the tendons will be cut loose so that the compressive stresses will be induced into the concrete element. Okay, and compressive stresses are induced by the bonding action between the surrounding concrete and the tendons. Okay, the pre-stressing will be done. Okay, the pre-stressing process will take place through the bonding between the hardened concrete and the tendons. Okay, in this way, the transfer of pre-stresses will be done. Okay, so I'll explain once again. In case of pre-tensioning system, the tendons or the cables will be stretched through the jack. Then concrete will be poured into the mold. Then it is allowed to get hardened for 20 days, minimum of 20 days. After the concrete gets sufficient hardening, after the concrete gets sufficient strength, required compressive strength, then these tendons will be cut loose so that the transferring of the pre-stress will take place to the beam element or the PAC element. Okay, and this transfer of pre-stress will take place through the bond between the cables or the tendons and the hardened concrete. Okay, in this way the pre-stresses are induced into the concrete element. This is what the pre-tensioning system. Okay, next is the same thing is explained here below. So if you please make some note of some important points. Okay, don't simply listen to the class. Wherever the figure comes, please note the write the figure, okay, in your notebook. Okay, so that you can have a better understanding. Okay, I hope this pre-tensioning is clear for everyone. Is there any doubts in this topic? Pre-tensioning system. Is there any doubt, students? Please reply, anyone. Okay, thank you. Now, the second method of pre-stressing is post-tensioning system. Okay, what will be the process involved in the post-tensioning system? Can anyone explain? Now we have seen pre-tensioning system. Now we have to study post-tensioning system. What will be the process involved? Can anyone explain? In case of post-tensioning system, what will be done is after pouring the concrete. Okay, after pouring the concrete, after the concrete hardens, the pre-stressing will be introduced or induced into the concrete element. Okay, here what will be done is, here you can see a circular opening throughout the length of the beam called as duct. It is duct means a hollow kind of hollow pipe kind of a thing. Okay, duct means a circular opening throughout the length of the element or throughout the length of the PAC element or PAC beam. Okay, that is called as duct. Okay, here what happens is, concrete will be casted by placing the ducts throughout the length of the element. Okay, duct means a hollow opening throughout the length. It is pipe kind of a thing. Okay, hollow pipe kind of a thing it is. Okay, it will be placed initially, then concrete will be poured and concrete will be allowed to harden, okay, so as to get the sufficient compressive strength. After that, the tendons will be placed. Tendons or the cables will be placed inside this duct, okay, inside this duct, okay. Then they are stretched to the required tensile stress, okay. They are stretched to the required tensile stress. After that, through some anchoring devices, okay, through some anchoring devices, here the edge of the both the edges of the cable or the tendon will be fixed at the both the edges, okay, by using some nut bolt arrangement or any other kind of arrangement, okay. In this way the pre-stresses will be transferred to the PSC member, okay. Are you understanding? Here what happens is the concrete will be casted by providing duct inside the concrete element throughout its length. After the concrete attains sufficient strength, the the cables or the tendons will be placed in taken through the duct and they will be stretched to the required tensile stress. After stretching, by using some anchoring devices, the cable will be properly anchored at both of its edges. Cable will be properly anchored at both of its edges so that the compressive stresses will be induced into the element, okay. So this is the process involved in post tensioning system, okay. So how the nature of stress, the stresses will be transferred here? How the stresses will be transferred to the element here? Through the jack system, okay, to the through the anchoring. By properly anchoring the cable at both of its edges, the transfer of stresses will take place. In the previous case, through the friction between, okay, or through the bond between the concrete and the cable or the tendon, the stresses will be transferred here through the by providing proper anchor, okay, anchor at the edges, the stresses will be transferred to the element. This is what the process involved in post tensioning system, okay. Now I will show you a video, okay, animated video, so that you can understand the concept of pre-stressing and pre-tensioning and post-tensioning system. Just go through it. Okay. Is it visible? I'm playing a video. Are you able to see that video, students?
Yes, sir.
Okay. Thank you.
Prestressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, prestressed concrete is being used. In prestressing, the rods or tendons are stretched along the axis and cement is poured. Later, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam. The principle behind prestressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Prestressed concrete can be used.
You can see that for roofs, floors, and walls, this pre-stressing is applied nowadays.
for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Prestressing is generally done by two methods: pre-tensioned concrete and post-tensioned concrete. Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before.
Now you can see the tendons are being stretched before pouring the concrete. Now further you can see after pouring the concrete and after the concrete attains a sufficient strength, both the tendons will be cut loose so that the pre-stresses will be transferred to the element.
For pouring of concrete, the tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensions after the concrete is poured. Initially, the concrete is cast around the sheathing.
I was telling about a duct, no? Duct. It is also called as sheathing. We will also call it as sheathing. Means the protection throughout the length of the beam for placing the tendons. Okay, it is also called as sheathing or ducts. Okay.
The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry.
And whatever the space left out in the ducts, no, small space, through that that space will be filled by the cement slurry or the cement mortar. Okay, so that proper bonding will take place. Sometimes it will be left as it is. Okay.
In the unbounded type of tendons, grouting is not necessary. We will learn about this later. Thank you for watching.
I hope you got some idea about this concept of pre-stressing, pre-tensioning system and the post-tensioning system. Okay, and there are few basic definitions which you need to understand for learning of this pre-stressed concrete. It is like prerequisite. We should be thorough with all these terminologies to understand the next coming topics of your pre-stressed concrete. Okay, and these terminologies have been given in code book. Okay, you can also refer the code book, that is IS 1343 code book. Okay, few terminologies have been explained, but few not explained, that I have written in the notes. Both I have written in the notes. At the beginning you have all these terminologies. Okay, so you can, this code book is allowed for your examination, but all the definitions are not available. Few definitions you need to remember. Okay, if it is asked in the examination. Let us go with one by one. Tendon, initially you already know, correct, in the introduction. Tendon is nothing but a stretched element used in the PSC to induce the stresses into the member. Okay, it is like reinforcement in the RCC elements. Okay, there we will call it as reinforcement, but here we will call it as tendon. Okay, there we will call it as reinforcing bar. Here it is called as tendon or the cable. Okay, it is an element used in the PSC structures to induce stresses into the member. Okay, that is called as tendon. Okay, then coming to the next terminology, anchorage. It is a device used to properly anchor the cable on both the sides. Okay, in case of post tensioning, the cable should be properly anchored. It's anchored at its edges. No, for that we have to use some devices. Those devices itself is called as anchorage. Okay. Next is bonded pre-stressed concrete and non-bonded pre-stressed concrete. What is the meaning of bonded pre-stressed concrete? The name itself explains its definition, correct? Bonded pre-stressed concrete means here you can see through the bond between, in case of pre-tensioning, through the bond between the cable and the concrete, the pre-stresses are introduced into the concrete, correct? That is why we can call this PAC element which are casted by this pre-tensioning system as bonded pre-stressed concrete. Okay, bonded pre-stressed concrete means the pre-stresses are introduced into the concrete through the bond between the cable or the tendons and the concrete. In case of unbonded pre-stressed concrete, here you can see there is no bond between the cable or the tendon to that of concrete. Okay, there is a gap between, means there is a duct inside. Okay, there is a circular hollow opening throughout the length of the beam. Through that opening, the tendons are placed and stresses are induced through that tendons. But there is no contact. Okay, contact between the surrounding concrete and the tendons. Okay, and the pre-stresses are introduced by properly anchoring at the edges. That is why it is called as unbonded pre-stressed concrete or non-bonded pre-stressed concrete. Okay, the bonded pre-stressed concrete will come in case of pre-tensioning system. For post-tensioned system, we will get non-bonded pre-stressed concrete. Then coming to the next terminology, transfer. Transfer means it is a stage where the transfer of pre-stresses will take place. Okay, it is a stage where transfer of pre-stress will take place. Then supplementary or untensioned reinforcement. Okay, there are a few structural elements which are not fully pre-stressed, which are not fully RCC elements. Okay, part of the reinforcement or part of it will be, part of the structural element will be pre-stressed, and along with that some reinforcing bars will also be placed into the members. Okay, so the combination of both will result in partially pre-stressed concrete element. Okay, partially pre-stressed concrete element means it is combination of PSC and the RCC. Okay, I hope you are understanding. Combination of PSC and RCC. There will be some reinforcing bars and there will be some tendons which are stressed and through which the stresses are induced into the concrete. Okay, in that case whatever the reinforcing bars we will use, no, that reinforcing bars are called as supplementary or untensioned reinforcement. Untensioned reinforcement means for these reinforcement we are not going to stretch or we are not going to apply pre-stresses through these reinforcement. Okay, next, transmission length. Transmission length means here you can see length from here to here, length from here to here means it is the length of stretch required for a tendon. Okay, it is the length of stretch required for a tendon to introduce pre-stresses into the member. Okay, length of stretch required for the tendon to introduce pre-stresses into the member. It is called as transmission length. Then coming to the cracking load, you all know about rest of the terminologies. Cracking load means it is a maximum load at which the first crack appears. Okay, the load at which the first crack appears is called as cracking load. Then creep, shrinkage, you already know. Creep is nothing but progressive increase in inelastic deformation. Inelastic deformation or the permanent deformation of concrete under sustained stress component. Okay, then shrinkage means reduction in volume of the concrete after drying. Why the reduction of the volume of the concrete will take place? reduction in volume of the concrete after drying is called as shrinkage. Why the reduction in volume will take place? Because the wet concrete or the fresh concrete, whatever we have, there the excess water which is required, okay, the excess water which is present, the excess water then that required for the hydration process, when it gets evaporated out to the atmosphere, okay, then what happens? Shrinkage of the concrete will takes place, or reduction in volume of the concrete will take place. Okay, there is a reason for shrinkage of the concrete. The excess water then that required for hydration process of the concrete, when it gets evaporated out to the atmosphere, okay, then contraction or reduction in volume of the concrete will take place. That is called as shrinkage. Okay, reduction in volume of the concrete on drying is called as shrinkage. Then coming to the next terminologies, relaxation in steel. What is the meaning of relaxation in steel? If you remember the stress strain characteristics of a mild steel, there is certain point where without increasing the stress, there will be increase in the strain of the mild steel bar, correct? Okay. Similarly, here there will be decrease in stress with constant strain. Okay, there will be decrease in stress with constant strain, that is called as relaxation in steel. Okay, so the load taking capacity of the member will goes on decreases. Parallelly, there will be constant elongation of the bar, that is called as relaxation in steel. Then coming to the proof stress you are already studied in your strength of materials. What is the meaning of proof stress? Here I have some stress strain curve at the last. Proof stress means, see here I written stress strain curve for high strength concrete. Assume that this is the stress strain curve for a tendon. Okay, assume that this is the stress strain curve for a tendon. Proof stress means it is the amount of stress, okay, required to cause 0.2 percentage of strain. Okay, 0.2 means 0.002 strain. Corresponding to this strain, whatever the stress we get now, so that is called as proof stress. Okay, so the proof stress means the stress corresponding to 0.2 percentage strain. Okay, the stress corresponding to 0.2% strain is called as proof stress. Okay, 0.2% strain means there may be increase or decrease in original gauge length of the element by an amount of 0.2%. Okay, at that particular point, whatever the stress which is there for the element, that stress is called as proof stress. Then coming to the next terminology, creep coefficient. Creep coefficient means it is the ratio of total creep strain to the elastic strain in the concrete. Elastic strain means, I will go to the graph again. Elastic strain means here you will have some elastic limit, correct? Where if you release the load, the element will come back to its original position. Okay. The ratio of creep strain means permanent strain. Okay. When the material undergoes permanent deformation or the inelastic deformation, then it is called as creep strain. Assume that 0.003 is the creep strain, and with respect to the straight portion of the graph, 0.001 as elastic strain. The ratio of this creep strain to the elastic strain is called as creep coefficient. This terminology you are going to use in the next model. Okay, that creep coefficient. Okay, I hope you are understanding. In between, if you get any doubts, you can ask. Then coming to the next terminology, cap cable. Cap cable means, so during the process of stressing, no, here we have a straight cable, correct? Here we have a straight cable. Okay, there are some advances happened in the technology where the cable profile will be different. Okay, depending upon the bending moment of the beam or bending moment of the girder, depending upon the bending profile of the girder, we will choose a suitable cable profile. Okay, to that cable profile the prestressing will be introduced. Okay, that curved the curved profiled tendons, whatever it is called as cap cable. Okay, they are called as cap cable. Okay, that this thing I will be discussing in detail in the next coming topics. Okay, next coming modules. Then coming to the degree of prestressing. Degree of prestressing means, see, prestressing, when we are doing the prestressing, 100% prestressing we cannot do because there are some loss of prestresses involved in the process of pre-tensioning or post-tensioning. Okay, there may be loss of prestresses due to the friction. Okay, loss of prestresses due to the relaxation of steel. Okay, there are so many reasons for which the loss of prestresses will takes place. Okay, if you want to do 100% prestressing, it is a practically it is a difficult task. Okay, around 5 to 6 types of losses of prestresses will take place. That these things we will be studying in detail in the next module. Okay, because of that loss of prestresses, the degree of prestressing will not be 100%. Okay, the degree of prestressing will not be 100%. And to represent what is the net prestresses happening in the concrete, we will use the terminology called as degree of prestressing. We will use the terminology called as degree of prestressing, which is defined as a measure of magnitude of the prestressing force related to the resultant stress occurring in the structural member. Okay, there will be a certain amount of stresses induced by the external loads, dead load or the lay load or the dead load. Okay, the stresses will not be contracted by the pre-stresses. Okay, so the ratio of the pre-stresses to that of the stresses caused by the external element is called as degree of pre-stressing. Okay, then coming to the last terminology, debonding. Okay, after a certain period of time there may be loss of bond between the tendons and the surrounding concrete. Okay, that loss of bond what we call as debonding. Okay, all these things will be taken care while designing a pre-stressed concrete element or while casting a pre-stressed concrete element. Okay, so this is about the basic definitions related to the pre-stressed concrete. Okay, few definitions are available in the code book. Okay, few definitions you just go through the notes. Okay, so that you can understand in a better way. Then coming to the types of pre-stressing. Okay, till now we learnt about pre-stressing technique, then types of pre-stressing. In case of types of pre-stressing, we learnt about the pre-tensioning system and post-tensioning system. After that, we gone through some basic terminologies. Next topic, what we have is types of pre-stressing. Okay, types of pre-stressing. In that, first one is full pre-stressing. Okay, full pre-stressing, as the name itself indicates. Full prestressing is prestressing to the 100% contraction of 100% contracting the external stresses caused by the loads. Okay. So the full pre-stressing means pre-stressed concrete in which tensile stresses in the concrete are entirely obviated or nullified at working loads by having sufficiently high pre-stresses in the members. Okay. 100% of the stresses caused by the external loads will be contracted by the pre-stressors induced into the concrete, that is called as full pre-stressing. Then coming to the partial pre-stressing or the limited pre-stressing, the partial amount of stresses will be contracted by this pre-stressing force. Okay, partial amount of stresses which are caused by dead load and the live load will be contracted by this pre-stressors then it is called as partial prestressing. Then moderate prestressing means it is the level between the partial prestressing or limited prestressing to that of full prestressing. Okay, here almost all the stresses which are induced by external loads will be contracted, but due to some unavoidable losses, moderate prestressing elements will be resulted. Okay. Then coming to the next next type of prestressing, that is axial prestressing. Okay, axial prestressing. Axial means what? Axial means what? If the prestressing applied through the neutral axis of the member. Okay, here if you have some neutral axis to the member, if the prestressing is introduced into the concrete through the neutral axis, okay, then it is called as axial prestressing. Okay, then it is called as axial prestressing. If the prestressing is introduced through the neutral axis of the member, then it is called axial prestressing. Then eccentric prestressing. Eccentric prestressing means there is some eccentricity in the line of action of the prestressing force to that of neutral axis. There is some distance between neutral axis and the line of action of the prestressing force. That is called as eccentricity. The prestressing will be done at some eccentricity from the neutral axis. Okay. When you do eccentric prestressing, then the effect of that prestressing force, okay, the effect of that prestressing force on the member, okay, means the nature of bending moment which is caused by the prestressing force on the member will be either of triangular shape or the trapezoidal shape. Okay, that I will be explaining in detail in the next coming models. Okay. Okay, that is called as eccentric prestressing. Okay, I hope you are all understanding. Axial prestressing means the prestressing force which is applied through the centroid of the member with zero eccentricity is called as axial prestressing. If the prestressing force is applied at an eccentricity E from the neutral axis, then it is called as eccentric prestressing. Then coming to the next type of prestressing, concordant prestressing. Concordant prestressing means, as I said before, the cables which are used in the member, they will not be having the straight cable profile. There are some other cable profiles we will use for using in the concrete member, like semicircular profile, trapezoidal profile. Okay, depending upon the bending moment which is caused by the external members. See, if a UDL is acting on the beam, what happens? If UDL is acting on the beam, what happens? It will try to cause the hogging bending moment. Okay. To prevent that hogging bending moment, whatever the cable profile which we will be using, if it is having a circular profile or parabolic profile, then it will have good impact in resisting the external stresses. Are understanding? Different profiled cables will be used in prestressing, not only the straight cables. Okay, not only the straight cables, you can also use a parabolic cable or a trapezoidal profiled cable like this. Okay, so this profiled cables, what we call it as concordant prestressing. Okay, the prestressing introduced or induced into the member through different cable profiles. It may be parabolic, or it may be semicircular, or it may be some other profile of the cable. Okay, through which the stresses are induced. Then that is called as concordant prestressing. Concordant prestressing. In case of axial prestressing and eccentric prestressing, the cable profile will be straight only. Cable profile will be straight only. But in case of concordant prestressing, the cable profile will be different. Either it may be parabolic or trapezoidal or triangle, whatever, depending upon the bending moment which is acting on the beam. Okay, that bending nature of bending moment varies with the different loading conditions. If it is a 2-point loading, then we will get a trapezoidal profile of the bending moment diagram. Correct? If a single point load acting at the center of the beam, then we will get a triangular shape of the bending moment diagram. If it is a UDL, uniformly distributed load acting throughout the length of the beam, then what is the shape of the bending moment we'll get? We'll get a parabolic shape of the bending moment. Depending upon the shape of bending moment caused by the external loads, we will choose suitable cable profile. Okay, suitable cable profile. Then the pre-stresses are induced into the concrete. So using different cable profiles other than straight profile and introducing the stresses is called as concordant prestressing. Is called as concordant prestressing. The next terminology is non-distortional prestressing. Non-distortional prestressing. Non-distortional prestressing means whatever the stresses which are caused by the dead load of the beam and okay the resultant stress which is caused by dead load of the beam and the pre-stressing force. Okay, if it is zero, then it is called as non-distortional pre-stressing. Okay, are you understanding? The resultant stresses. Okay, resultant stresses means the combination of stresses due to the dead load of the member and due to the pre-stresses applied. If it is zero, then it is called as non-distortional pre-stressing. Okay, this much you remember. Then coming to the next one, uniaxial, biaxial, and triaxial pre-stressing. This pre-stressing, no, it will not be done in a single direction. It depending upon the requirement, in multiple directions we can do this pre-stressing. Okay. If the pre-stressing is done in only one direction, then it is called as uniaxial pre-stressing. Then if the pre-stressing is done in two mutually perpendicular directions, then it is called as biaxial pre-stressing. If the same pre-stressing is done in three mutually perpendicular directions, then it is called as triaxial pre-stressing. Okay. Coming to the last terminology, circular pre-stressing. Circular pre-stressing means if you want to go for the pre-stressing of some circular pipes or the tanks, okay, then whatever the pre-stressing we do for this round members such as tanks and the pipes, then it is called as circular pre-stressing. Okay, these drainage pipes you can see those pipes are pre-stressed elements only. Okay, throughout the periphery the tendons will be placed. Okay, and stretching of the tendons will be done and the stresses are induced into the circular elements. Then it is called as circular pre-stressing. Whatever the pre-stressing we do for circular elements such as tanks or the pipes, then it is called as circular pre-stressing. Okay, I hope it is clear up to up to here. If you have any doubts, you can ask. Whatever the topics I have covered till now, in these topics, if you have any doubts, you can ask, students. Any doubts in these topics? Okay, students. Okay, third hour also you have PSC only. So we will take 10 minutes break. Okay, we'll join exactly at 11 o'clock. Okay, we'll join back at exactly 11 o'clock through the same link. Okay.